quantum mechanics originally arose from the study of radiation, which relates to the meaning of the word quantum. But a simple comparison between two seemingly distant phenomena can paint this picture in a less abstract light, pun intended. If you think about an electron orbiting the nucleus of a hydrogen atom and ask how that differs from the moon orbiting the Earth, one of the key differences you will find between these two phenomena begins to show both the meaning of the word quantum and how it relates to radiation. I'm going to ask you to use your imagination here because a quality visual is just not in the time or energy budget right now. Plus, a little bit of imagination is healthy in physics. Now, if you imagine our moon orbiting the Earth, you might know that its orbit is elliptical, so it moves in an elongated circle around the Earth. But the key thing is that the moon's orbit is actually expanding gradually, moving farther away from the Earth due to essentially the tides slowing the Earth's rotation and the law of conservation of angular momentum. But don't focus on that. Focus on how the moon is continuously moving farther away from the Earth and gaining energy. It's just not visible to the naked eye because it's happening very slowly and continuously, which is a key word here. You can imagine a process where a supervillain might be ramming asteroids into the moon to alter its orbital angular momentum or energy, or you could just say modifying its orbit, making it move more quickly, more slowly, or closer or farther away from the Earth. But you might know intuitively that you could launch 5, say, asteroids of the same shape and mass into the moon at slightly different trajectories, and it might have 5 entirely different effects on the moon's orbital angular momentum, or orbit. Now, when it comes to an electron in a hydrogen atom, or any atom, this is not how a change in orbital angular momentum or energy works at all. There's actually another word people use to describe the orbits of electrons similar to quantum. People say that they are quantized, or divided into discrete levels, values, or categories. Actually, the most common way for an electron to gain energy is not for the nucleus to lose energy relying on the law of conservation of angular momentum, like the moon with the slowing rotation of the Earth, but rather for the electron to absorb a photon, a particle of light, or radiation, also known as a quantum of light or radiation. Now, the fact that the radiation or light comes in particles or quanta, plural, is key here because each photon provides a defined amount of energy to the electron that absorbs it, depending on its color, regardless of trajectory. And that determines the new distance from the nucleus, energy level, or orbital to which the electron jumps upon absorbing the photon. So as its energy increases, it's not a gradual, continuous process. It more so gets punched by the photon with a certain amount of energy packed in, and thus gets launched, in the sense, a certain defined distance to the appropriate energy level, the same distance away from its original energy level or orbital every time for the absorption of a photon of the same energy. And it's always an increase in energy too for the absorption of a photon by an electron, but by a fixed amount of energy, and this is the photon's color. The energy levels are depicted as rings in the Bohr model of the atom, which cannot expand or contract. And if there's no energy level or orbital the appropriate distance away from where the electron is originally, regardless of whether there is too much or too little energy in the photon interacting with the photon is simply not absorbed and passes right through the electron with no interaction. This is the fundamental rule of quantum mechanics that gives it its name. Anything that's quantized or quantum has discrete levels, values, or categories with no occupiable levels, values, or categories in between. That's all. It turns out that this has some shocking baggage for the universe when introduced as a new law of physics, even at such a small scale of atoms. I intend to upload more videos on isolated explanations of specific rules of quantum mechanics and eventually how they relate to the field of quantum biology. So you can subscribe and look out for those if you're interested. Thank you for watching.